Hi, in this lecture we are going to discuss about the Decorator Design Pattern, which is a composable alternative to subclassing. So the goals of this lecture is to think about Decorator, the Decorator pattern, to discuss about the different inconveniences and the benefits of it, and to think about APIs in general and how actually APIs will have an impact on the different designs of the Decorator pattern. So from the book, the Decorator will help you to attach new responsibilities to an object dynamically. What does it mean? Is that we are going to have an object and then we are going to attach some other object that will extend this the behavior of this object. So this is a way to actually attach behavior by chaining objects and not by extending classes like in inheritance. So the main point is that dynamically we can decide if this decorator will be there or not at runtime. That is why it's said dynamically. Now, if we look at the main drawing, the main design of the decorator in UML, what we see is that we have a client. The client is the object that is going to use the decorator, and we have here the main decorator part. So the decorator is either what we are going to say a decoree, which is the main object. It is the object that is going to do the main operation. And then we are going to have decorators that are going to wrap this decoree to extend the behavior. And by default, a decorator will know the decoree and delegate the operation to the decoree. So that means that every time that we have a decorator, a decoree, and we have a decorator, the decorator knows the decoree, and then every time that we are going to say, do operation to the decorator will do something, and then eventually will tell the decoree, do operation. So it's a pattern really based on delegation. Of course, you can mix this with inheritance. You can have many different ways of decorees and many different decorators. So as much as you want, as many as you want. And what will happen is that at the end, the only objects in the dynamic graph that no other objects here will be the decorators. So the decorators can be chained in a way that we have a decorator, a decorator, a decorator. But the decorees will be leaves. So they will be the end of the chain. So the decorators will be the leaves here. So here we are going to see the decoree. So a decorator, we say it wraps an instance of a decoree. It is placed between the client and the decoree. So in my drawings before, I didn't put the client. But actually, it is one of the most important parts in the decorator pattern when taking the decision of deploying it or not. So here, for example, we have a decorator, a decoree, that is going to be decorated by some decorator. And the client is the one that is going to be using the decorator here, and the decorator is going to delegate something to the decoree, and the decoree is going to do its operation. So what is important here is that the messages will actually flow from the client to the decoree. So the decorator can do many things. It can intercept messages. It can decide, for example, to do something before, after, or instead the decoree. So it can also, the decorator can decide to not delegate to the decoree. One thing that happens is that decorators can be nested. As we saw before, decorator can know another decorator. And all this chain of decorators are transparent to the client. So a client, actually, will have probably some piece of code that will say object operation. But here, the object could be a decorator or it could be the decoree. So actually, the client is completely independent of how the decorator chain is composed. It could be just the simple decoree, or it could be actually a chain of decorators followed by the decoree. What's important here is that there is a really strong implication the decoree and the decorator must expose the same API, because the client should be agnostic of that. It should be agnostic of the fact that it's being talking to the decoree or the decorator. So decoree and decorators should have the same API. If we see an example here with streams, so here what we see is that we have a binary stream accessing the standard input, output. So here it's a standard output. The standard output, of course, it's a binary stream. So it just knows how to write binary data in zeros and ones. And if we want to put text in there, we need to encode that in some encoding. So what we're going to do is we have our stdio object. And if we want to write text, we need to decorate it with a character stream. What is the responsibility of the character stream? The responsibility of the character stream, of course, is to receive text and transform it into bytes. Of course, we can, again, in this example, wrap this character stream with another decorator, which is a decorator that will add new lines, and it will manage how they are printed, independent of the platform. And here, every time that we give text to the new line decorator, it will transform the text to replace the new lines for some platform to a more, maybe for the current platform. There are many ways to wrap those streams. So here, for example, there is another example in the file class, the file reference class. Every time that we want to read a file in Faro, we're going to ask the file for a stream, a read stream, with an encoding. Dynamically, the file reference will decide to create a binary read stream and to wrap it with a new character decorator using the encoding that we asked as parameter. So dynamically, it is the file reference that is deciding to create and wrap the binary read stream. If we want to check the implementation of this, of course, here we have the new line write stream that knows, for example, the stream, which is the decoree, and it knows several data that it uses to actually replace the new lines. So for example, here it knows the CR, the LF characters, the previous character, and the line ending that is going to be replacing. And then it needs to implement all the basic API of streams, like for example, close and flush, to be able to be polymorphic with the original stream that is going to be wrapping. So here we see the close method is going to just call the close method in the stream, or the flush method is going to call the flush method in the stream. Now, here what we see is a test that is actually testing the behavior of our new line stream. What we're having here in this first line is string composed by AB, and in the middle we are going to have a new line depending on the current platform. So if, for example, if we are on Windows, we are going to have a CR, character return. And if we are in Linux, we are going probably to have a line feed followed by a carriage return. So depending on the platform we are on, we are going to have different line ending conventions. And then what we're going to do is to craft different strings using different line endings. So here we take 3 different line endings, just CR, LF, and CRLF. We are going to craft a string using that line ending, and then we are going to write it using the line ending write stream to see that it actually matches the string that we expect. So here we are testing that our new line writer stream is actually transforming the different line ending conventions to the expected string, which is the one of the platform. Now, if we take a look at implementation, the new line writer stream, as I showed you before, it will just redefine most of the method to call the decoree. But here, it needs to manage what happens when we try to put a character in the stream. So when we want to write a character in the stream. So what it is doing here is that every time that we're going to write a character, it is checking first the previous characters and the current character to see if they match the CR, CRLF, or the LF pattern. And in that case, if it matches one of those, it will just write a new line. Of course, this new line will follow the current platform new line, as we saw before. Otherwise, if it doesn't match any of those, that means that it's probably just a normal character, like A. And if it is the case, it will just delegate the writing to the decoree. So calling the stream and saying, okay, next put this character. What we just saw before is that all decorators should have the same API. So in this case, close, flush should be redefined to just delegate to the decoree, but then next put, contents, next probably need to be redefined and specify specific behavior for our decorator. Now, one of the benefits of this decorator implementation is that the decorators can be shared and replaced by different kind of decorators. So we can compose different chains in different ways and obtain different behavior. We say that decorators attach additional responsibilities to an object. Yeah, so we have our object, the decoree, that is going to be wrapped by a decorator. And the decorator will actually delegate behavior to the decoree. Now, as we saw before, in the example of the file reference, it is the file reference that is creating the pair or the chain of decorators. So we should really control how the decorator chain is created, because the client actually doesn't know if it is talking to the decorator or to the decoree. So before actually giving the reference of our object to the client, we need to create the correct chain with the correct configuration and give it to him. There is a strong implication also on this, is that if we have a client here, of course the client doesn't know which kind of object it is talking to, but the decorator, it doesn't know either if it is being used by the direct client or by another decorator. And it is also the case for the decoree. The decoree doesn't know if it is used by a decorator or by another client. So this means that changing the decoration chain or removing one decoration in the middle of the execution is not an easy task. So there is the design pattern is actually not made for that, and doing that adds a lot of complexity to the code. So when you should not, or maybe it's difficult to use the decorator, when the decorations should have different APIs. So the main point of using the decorator is that both the decorators and the decorees have the same API, like that the client doesn't need to check anything, it can just use them polymorphically. If they have different APIs, that is by construction impossible to do. So we cannot apply the decorator pattern in that case. Of course, if we need to change the decorator chain dynamically, it also complexifies the task of using decorator. So maybe we need to think twice before doing this. Maybe the decorator is not the best solution for the case. Also, it happens that sometimes APIs are huge. Maybe you have hundreds of methods. So that means that maintaining huge APIs where decorators will only override one or two methods, maybe it is not worth to have a decorator in that case. In conclusion, today we saw that decorators can represent composable facets of an object that can be reusable and even dynamically composable. We should pay attention that all the decorators should implement the same API, and the decorator pattern is a modular pattern, but it expects us to have a common API.